Hello, everyone. Welcome back to another TechStrong Learning event. Very happy to, my name is Alan Schimmel. I'm the CEO, founder of TechStrong, and I'll be your host today. I'm really happy to present to you, well, what for us is a new company with a new solution, a new open source project, excuse me, that will introduce you to today. And you know, in today's world where we're all looking at AI and how are we going to run AI and everything that comes with AI workloads and AI factories and so forth, you know, we're seeing a lot of innovative solutions come to market. And I think this company and this project that we're going to introduce you to represents one of the best of them. The name of the company is DevOps. The project / solution is Cloudy. It's cloudy.io. It's open source. And we're going to be joined today. Well, we're going to be joined by a few people today. But initially, I want to introduce you to Bernard Hallis. Bernard is with DevOps. Bernard, welcome. Thanks for being here.
Thank you very much. Hello, everybody.
Hello. So, Bernard, I'm going to come back to you in just a moment. But first, I want to take a few minutes to familiarize our audience with the Big Marker communication window, because that's how they'll be communicating with us. You know, we use this webinar platform called Big Marker. It's a web-based platform, no plugins or anything. For most of you, the Big Marker communications channel or interface is in the right-hand corner of your browser window. And the first thing you see there is the word chat. It makes it real easy. Underneath chat, you'll see public or private. We only use public chat here. So that's how you can communicate. You can see Bernard and I have already said hello. We'd encourage you all to come in here and say hello as well, just to make sure your chat works. But more importantly, as we're going along here, if you have any questions, comments, thoughts, use the chat to put them in there. We'll do our best to answer your questions, raise up your comments, and try to get us all on the same plane, if you will. Next to the word chat, there's also, it's grayed out for most of you, Q&A. If you have a question really specifically for Bernard or any of our presenters here today, if you go into Q&A and put it in there, I personally will, raise it up to the panel and we'll do our best to answer your question. Additionally, we are going to be doing some handouts today, actually a few handouts. We find our audience really loves to be able to take some of this stuff back with them to study later, to reinforce what was covered. And so if you go into your handouts, you should be able to, if you want to download or preview the handout now, we'll make sure we get everyone available for those handouts by the end of the day. I see we're actually joined. It was going to be touch and go if he'd be here but he got here early, right as we started here. Let me also introduce you to Amir Shakir. Amir, thank you for joining us today too. We appreciate it.
Yeah. Pleasure to be here.
Okay. So, guys, let's introduce, beyond your name, let me let you introduce yourselves to our audience today. Bernard, why don't we start with you and introduce yourself to our audience?
Amazing. So, hi, guys. I'm Bernard Hallis. I'm the founder of DevOps. I'm calling from Slovakia, Central Europe. And I'm looking forward to talk to you about the AI workloads today and the infrastructure that you might need for running them.
Excellent. Bernard, thank you. Let me quickly also, though, introduce Amir, or allow Amir actually to introduce himself. And then, Bernard, I'd like to turn things over to you. Amir, go ahead.
Yeah, sure. So, hey, guys, I'm Amir. I'm the founder of CEO of Mixbread. Yeah, I'm a researcher, or previously my previous life was a researcher at information retrieval and AI. Was doing it for 7 years before starting building Mixbread. And Mixbread is a small research lab around search and retrieval. And we are building basically an AI search engine where you can upload any kind of data, make it searchable, like videos, PDFs, audios, whatsoever, and make it useful for AI systems. And we are onboarding one of the largest companies on the world onto the systems with the help of DevOps and Claude.
So if you allow me, Alan, let's dive right in.
Yes, please.
Amazing. Brief background about me. So my major is networking and computer science, and specifically distributed systems within the field. My career went through software engineering fields, evolved into DevOps, and for the last 8 years, it's around Kubernetes. As mentioned, I'm the founder and CEO of DevOps. DevOps is a consultancy business around Kubernetes. And while interacting with the market, speaking to customers, seeing their pain points, the idea of Claude as a solution to some of the pain points came about. So we are the authors of Claude, and we operate Claude and develop it further. Let's talk briefly about the agenda that we have prepared for today. I'm going to give you an intro about the AI workloads. What are the main categories? We are going to skim through the leading orchestration tools and platforms. It's going to be rather like looking at the tip of the iceberg than a comprehensive overview, but just to give you the idea about the variety that's out there. And then we're going to open the core of the subject, like what is the infrastructure required for running these solutions, these systems, and essentially the AI. This poses a couple of challenges, and we will look at how can we overcome these challenges so that people like Albert in the chat and the rest of you as well can advise your customers, your colleagues on building the right infrastructure for your AI workloads. All right. When we speak about the AI workloads, we can speak about different things and different requirements. Model building and model deployment are two different stages of a life cycle, and they have different requirements. If we break it down, still in a fairly coarse manner, we can talk about 4 phases. For good and successful model building, we have to have a data preparation. It all starts with that. With a good quality data set, you can expect that you will have a good model. For the data preparation phase, we often talk about ETL pipelines. ETL is actually extract, transform, and load. These are the pipelines where you prepare your data for model training. This phase is somewhat intensive on compute and network, and depending on your use cases and the size of the data set, it can be somewhat intensive on storage as well. Once you have this done, you move on to a pre-training phase. This is the most intensive phase in the life cycle of your model. Typically, therefore, it runs on powerful GPU or TPU units. Just to give you an idea, the GPT-3 model training needed 355 GPU years. Of course, it was parallelized, so essentially it was faster, but just to give you the idea of how intense this phase is. This is a memory and bandwidth intensive stage of your model lifecycle. And the distributed systems need to have high-speed network interconnect. We are talking at least 10 gigabit per second. Then we move on to fine-tuning when you further tune your model on specific smaller data sets. So this is a less demanding stage. And the last one is the deployment, also called inference, where the model is actually serving the value. It responds to the user queries, it provides information, it provides answers. The footprint per single request is small. But the thing is, if your deployment is successful, if the value is there, you will have thousands of users. All in all, many companies actually find themselves spending 80 to 90% of overall infrastructure cost on inference phase. So it's very important. This phase is latency sensitive. You want to provide your answers quickly. And GPUs are also used in this phase for parallelizing the work. Of course, you need to have some reasonable load balancing in front of them to balance the requests across your infrastructure. So this is a quick intro so that we are on the same page. You want to move on, you want to build an AI, and you want to train your model, you want to run your model. Which tool to go for? Well, the landscape is vast. Let me briefly mention a couple of tools you might come across. Metaflow and Dask. So these are Python libraries. Metaflow is used for machine learning and data science. Dask is used for data processing. You might come across ZenML. As you see by the name, again, machine learning oriented and large language model pipeline framework. Horovod is a training framework. So these are two frameworks. You might come across orchestrators, Seldon Core, or orchestration platforms like MLrun. You might actually find your Horovod workloads run in MLrun, so you can actually encapsulate things into one another in some cases. Ray is a complex AI workload engine. Good functionality, very good reliability. You might find specific platforms, for example, just for inference, like BentoML. And then if you're building a bigger AI platform for your team and you decide to do it on Kubernetes, Kubeflow is like an umbrella of a variety of Kubernetes native tools for building the platform for you. All these things are open source. And I'm not even mentioning commercial platforms, Lambda AI, Anyscale, Rampot, or Model. So, and they're like every week there is a new solution out there. So the movements are quite strong. It's difficult to follow, and it's difficult to figure out how to operate this, how to deploy this, how to run this. You know, in the AI hype that we are living right now, there are huge opportunities. So everybody's building something, and everybody's trying to figure out how to add value by integrating agents, models into their solutions. And if it's not you who does that, it's going to be probably your competitor. Yeah? So there is a big pressure. However, the challenge is the following. You need lots of compute power. You will use GPUs, but GPUs are expensive. You need fast network, but fast network is expensive. You need fast storage. Guess what? That's also expensive, right? So either you pay or you figure out a way how to get the most in terms of, you know, the value/cost ratio. This is where I would like to go to. So what can we figure out in this huge landscape, this vast ecosystem? We're looking back at the sample of the tooling you might come across. They have a couple of things in common. So one thing is the open source factor, but more importantly, they all are Kubernetes compatible. They all run on Kubernetes. Why is this important to realize? If you're trying to figure out a cost-efficient way how to deploy the AI workloads, Kubernetes is probably a good interface to go with. That's the first thing. The second thing, how to optimize on expensive hardware. Well, with the boom of AI, there is a boom of providers. These providers, sometimes referred to as neo-cloud providers, offer cheaper hardware. But where is the compromise here? When we talk about the GPUs, you might come across providers that offer consumer-grade GPUs with almost the same power as the data center-grade GPUs for the fraction of the costs. There is a trade-off. You might find one of the trade-offs being, let's say, the SLA or the reliability aspect of this hardware. Let's not forget we are talking about distributed systems. Speaking of Kubernetes and distributed systems, we have the APIs and mechanisms to be able to recover from, for example, a hardware malfunction of one node. Of course, things need to be set up properly for this behavior to take place. But it's a good design choice if you decide to run your AI workloads in Kubernetes. But then the challenge is, how do I build the infrastructure? Okay, so let's say it's going to be distributed. I need neo-cloud providers, so the smaller GPU hardware providers. You might need to mix and match a different kind of providers in the same environment. So for example, the ones that have fast storage as well, for your data prep phase. So how to do that? So this is the essence of Claude. So Claude is a Kubernetes distribution with which you'll be able to deploy a Kubernetes cluster across multiple cloud providers, single cluster. There are solutions for multi-cloud deployment, but the core difference is that with Claude, you can do multi-cloud on a cluster level. So you can have one cluster with nodes from AWS, with the nodes from your on-premise data center, and for example, with the nodes from a neo-cloud provider. Your workload will be able to communicate in this environment without any hassle on a secured, encrypted communication line. And all this is managed through a single, simple YAML input manifest. So I think now would be a good moment when Amir could tell us a little bit more about the challenges they had. So before settling on using Claude in their infra environment, if there were alternatives that, for example, you guys considered. And by the way, how does your stack look like? Yeah, what do you rely on from the vast ecosystem of AI tooling?
Yeah, sure. So we train our own embedding models. So for people who are not familiar with AI, embedding models are like the core part of the AI infrastructure, which people need to get the right context for the AI. So imagine using ChatGPT, right? And you're using it for some client data or want to use it for your own code base. You need to somehow get the right data based on the problem you have to the LLM. And embeddings are basically a smart way of searching and getting the right data so it gets to the AI. And we built really good models. So if you guys are familiar with Hugging Face, we are one of the most downloaded models on Hugging Face in 2024. We contributed to over 5% of the traffic to Hugging Face, and basically everyone in the space uses us. And since we have so much traffic on our open source model, people also want to run the inference, right? And back then, embedding models have the nice feature that they are not too big, so they can run on smaller GPUs. But the issue is the smallest outdated GPUs on all the hyperscalers, like, is almost 4 times the price you can get on new cloud providers. So we were running, for example, before on AWS, and we had just free credits, like 200K or something. And then we just rented like 8 GPUs and just let it run for a year and just burn through all the credits. And there were like T4 GPUs, which are were built in 2016, like almost 10 years ago, and we were just using that for this back then. And now we have a new product, which is the search engine, where we have distributed workloads. Like people can come with millions of documents, and then we need to run the inference. So meaning we need some elasticity in the GPUs and need to spin them up and spin them down the whole time. And before using Claude, we were using it on Google Cloud, and we were dynamically spinning up and down machines. And with the first users we had, they're not big users, they're normal users, we were spending almost like between $20,000 and $30,000 per month for the bare minimum setup, because the GPUs are just super, super expensive. And so how our tech stacks actually in general looks like is we have a CPU pool, so where we spin up and spin down workers in the CPU, and the GPU pool where the inference runs. And the workloads are distributed using Ray. Ray is a distributed compute platform in Python, which is written in C++ and has a nice Python wrapper, which just distributes the workload. And this whole thing is running in a Kubernetes cluster. This is how we got started before we went to Claude.
Really exciting. And did you see, what were the effects that you have seen? How difficult was it to onboard Claude into your infrastructure? And what did you observe?
Sure. So the interesting thing is, so when we got the first bill of almost 30K or something from Google Cloud, we're like, damn, our runway is going to away really soon if we do it like this. So we knew that we need to change something. And so the idea was pretty natural. We were really happy with the CPUs on Google Cloud. How can we get to the GPUs at so then we basically were like, okay, hey, can we get the GPUs somehow from somewhere else? And Ray, like our core engineer and me, spent a lot of time trying to figure that out. So we tried a lot of different things and so on and so forth, and nothing worked. So if you ever, I don't know if you ever did that, but if you ever search for hybrid cloud on Google, the first 5 results on Google pages are just management slides from McKinsey and BCG and so on, where they're pitching some large customers and governments how they can set up a hybrid cloud architecture. But you don't find any real product. And by some accident, Ray found Claude, and basically we spent almost like a week trying to make it happen. And Ray came 30 minutes later, or our core engineer came 30 minutes after he discovered that, oh, look, Amir, the prototype is working. We can use it. And this was the moment where like, oh, damn, this works really, really well. And it does everything we want. So the core thing for us was we want to be able to have elasticity on GPUs, meaning being able to just scale them up, scale them down, like you would expect from Kubernetes. 2, we want to have the flexibilities of the parameters we want to use. And Claude allows us to do that by just adding it as static compute, right? So we can just provision, for example, a bunch of GPUs and just add them as static nodes. And 3, we need machines with a lot of CPUs and dedicated CPUs for our databases, because vector search is quite computational heavy. So we want to also able to add our own servers basically into the Kubernetes. And Claude basically enabled us doing all those entities. And this was the main reason why we started using Claude. And then we quickly realized, okay, we don't know anything about Kubernetes and how to use all those things. And that's where we also started working together with DevOps and the team at Claude. And they helped us basically to get started basically in no time. And I believe that the product we built right now and also how cost effective it is wouldn't be able without using Claude. And if people want to use AI in the future, especially local AI, this is going to be the way forward.
Amazing.
I'm sorry, I was on mute. That is excellent use case, Amir. Thank you very much. Bernard, back to you.
Perfect. So guys, if you have stayed with us for this long, we would like to trigger an offer for you. If you are considering, if you have questions about AI workloads, how to deploy them, how to run them, reach out to us. we will be happy to have a conversation with you. Doesn't have to be about Claude, doesn't have to be about Kubernetes, basically everything AI workloads related. But of course, we'll be happy, for example, Claude fits your use case, and we can explore that a bit further. So a couple of highlights. With Claude, you get auto-scaling. How it differs from competitors, it scales to 0. Yeah, that's important. With competitors, you rarely can scale to 0. In most cases, you can't actually. Supports on-premises hardware. So if you are a mid-sized business or an enterprise that already invested and has the hardware available, you can hook it up. Claude is able to manage that and integrate into a large Kubernetes clusters. And of course, it supports all the major cloud providers, the hyperscalers, the top 3 or 4, if we talk about Oracle, and some of the neo cloud providers as well. You might find that, for example, your favorite neo cloud provider is missing. So we have a way how to integrate it, and it's not a lot of effort. So just reach out. Yeah, we'll be happy to add the support to your particularly favorite or desired neo cloud provider. It's open source. We have designed an API how to customize Claude further. So for example, if you want to tag the machines, if you want to label them, if you want to customize the storage, if you want to customize the networking, everything is open source. We also rely on open source tooling inside Claude. We just stitch it in a clever fashion together. So if you want to customize things, we will be happy to assist you there. And as Amir said, it allows you to run your AI way cheaper. Yeah. So I hope you have seen the offer in the meantime, because I can't see it in the webinar interface. If not, you'll see it any moment soon. If you guys want to follow up, please check out claude.io. That's a good starting point. Check the SLAs, check the docs, check what we are building. Feel free to reach out on Claude channel in Kubernetes Slack. Our engineers are there. We'll be happy to assist you in your questions. Or feel free to reach out directly to me, via email, for example.
Bernard, I am seeing the pop up on my screen now. So I'm assuming everyone else is as well. And you can book. Look, how often do you get a chance to do a free review like this? You can book now right there.
Amazing.
Bernard, while we're at that, though, what about the handouts? Or I'll ask Jared on the back end. Can we move the handouts over to people or make them available for download? Yeah. And again, for most of you, that's in the top or in the right-hand column of your browser. If you go to where it says handouts, there's some excellent stuff in there. Bernard, and as well as Amir, let me, if you don't mind, I had a few questions. So we're seeing so much. I was talking about, say, on TechStrong Gang, so much interest around, modernizing in order to run AI applications, right? And this goes, it's a worldwide thing. It goes across every single cloud, public cloud as well as private cloud. It's almost, if it's close to universal as anything gets. Why is Cloudy so uniquely, why is it the right tool, right? Bernard, you went through all the tools. There's a lot of tools out there. And some of them, I'm always hesitant when I see a tool that has been pivoted, if you will, right? So the tool was originally designed for something else. Now it's good for this. Why is Cloudy the right tool in your mind, Bernard?
We made the right bet. Kubernetes is, in my opinion, a great interface for running any distributed workload. And AI is all about distributed workloads. Mm-hmm. But then you have basically two options. Either go with hyperscalers that have a huge service portfolio but they are expensive. That's one way how to go forward. Or you try to kind of outsmart the situation and you try to build something that leverages on the opportunities of the new, smaller cloud providers. Yeah? And this is exactly the niche that we are after. To combine the properties of the new gen cloud providers with they might not have a rich service portfolio, but this is exactly the gap that Claude patches, because we put Kubernetes on top. And if you have Kubernetes, you have an API for pretty much any distributed cloud-related workload. And you have seen that. I mean, I have just skimmed through a couple of toolings. They all have Kubernetes support. If you go with Ray, if you go with whatever, Dask, all the tools that I have listed, they all run on Kubernetes. So Kubernetes is a safe bet if you decide to manage your infrastructure underneath the API. There are discussions, right? There are discussions. Is Kubernetes like absolutely the right solution for all the workloads? Very specific discussions out there. But the fact is that 95% of AI workloads running Kubernetes. So in my opinion, it's the best that's out there for now. Yeah. But there are new solutions coming up every week. But this is where we are right now.
Excellent. I wonder, so with all due respect, Bernard is the president, right, of founder. You're a real life customer, Amir. Let's, you talked a little bit about, your process of how you guys decided here, but, you've got your finger on the pulse of this market. What do you see? Even since you've made the decision, I imagine you're still looking, right?
Yeah, of course. As I mentioned, I think Claude is the best thing existed in AI. So the thing is, I believe a lot of people are not aware how bad the tooling in AI is. So Bernard showed all these fancy tools, right? But using them and scaling them is another beast. And that's why OpenAI and all those companies have a really dedicated big team of just people who are managing the clusters and the compute. And what Claude allows you, right, is basically having a reliable way and a really cost-effective way to bundle all those tools together and run it without having to think about it and without having to change any primitives, And I believe that we will see this trend more and more, that people want to have distributed workloads, because right now we're already seeing that with other founders and other companies in the space, that they are using different clouds for their GPU. So some are using AWS, Google Cloud, Base 10, and some other things all at the same time. And they have some issues managing all those things. And this will just happen like this because some providers has those GPUs, some provider has those GPUs. They all fight for pricing, and you want to be always at the place where you have the cheapest possible flops, like floating point operation, right? And Claude provides you an easy way to do that.
You might actually find yourself in a scenario which is challenging. So imagine a world without Claude. You decide to go for one of the GPU-specific provider, which is cost efficient. If you start digging deeper, you start deploying things, you might actually see that the demand is so high currently for the GPUs that they run out of the hardware available for rent in a couple of regions. And what can you do now? Because you want to scale, right? You want to accelerate your business. You want to provide the value, but they don't have the hardware for you. So this is an amazing scenario, because with Claude, we break the barriers. You can integrate another cloud provider that has the GPUs available in your region just by providing minor inputs like credentials. Yeah? Actually, I have a simple input manifest open here, and I can show you how the input for Claude looks like. So let me bring that on the big screen. So this is an example how a simple input manifest looks like. You define the providers that you want to use for your setup. So in this case, this is a demo input for Cloudflare DNS and for Azure. So Cloudflare DNS means the DNS is hosted on Cloudflare, and some of the compute is on Azure. But then you might have an on-prem hardware that you would like to integrate. So how you do it? We define node pools for the CloudImate cluster. Azure Control Plane and Azure Compute are two node pools, both hosted in Azure. One is for the control plane of the CloudImate clusters. The second one is for the compute plane of CloudImate clusters. And here comes your static on-premise node. You can have multiple such static nodes. This is as much as you need to integrate a static node into the setup. Yeah? And if you decide you want to expand, you want to go to another cloud provider, well, basically you add a block like this, and you say GCP compute, or you say NeoCloud GPU compute. So this is as much as you need, and then also provide credentials. And your cluster automatically grows into the desired cloud provider that you just added. Right, so the input manifest is really simple to work with. We have defined same defaults, but also escape hatches for you to override, right? For example, if you do not like the size of the storage disk for the OS, we can tune that. There are a couple of perks and tweaks like that. Here we are setting, for example, that the compute node pool uses autoscaler. So you can define the boundaries for the autoscaler to work with. If you deploy more workload, it's going to scale automatically. You can have more than just one such autoscaler node pool in your setup. So it's really easy to work with. Yeah. Guys, let me know if you have any questions. I'm gonna hang around a bit longer to answer them. I'll be happy to take them up if you have any. You're muted, Alan.
Sorry, I hate muting. I always forget to unmute. I did ask in the audience if there were any other questions. And sometimes, sometimes it's like this with the audience. They take it in, they like the handouts, but they don't necessarily come forward with questions. But if we don't have any, Amir, first of all, I want to thank you, right? It's so hard. It's so hard to find a real live customer who is willing to come forward and talk publicly about their own situation and why they chose a product. So thank you very much for coming on here and sharing with everyone. Bernard, look, this is such a explosive market right now, right? I know actually there's a video interview with I just recorded it yesterday. It'll be out in a day or two, coming up on TechStrong TV, where we also dive into Cloudy and so forth, that I would recommend everyone check out. But it's changing week to week, month to month, right? And so it's important to pick a partner who, like Bernard here, is really on top, has his finger on the pulse of this. So I would highly recommend you keep an eye on what Cloudy's up to. It's an open source tool. It's on GitHub, and of course Cloudy.io as well. So do check that out. But if that's it, we'll call a wrap on this TechStrong Learning event. Thank you very much for joining us today. We'll see you next time. This is Alan Schimmel. We're out.
Thanks for having us.